Hey, what's up guys? My name is the Cherno and welcome to episode 94 of Game Programming. So we've got a pretty exciting episode today because we're going to talk about how our chaser is actually going to work. So what we have right now, just so you guys can see, is we have a bunch of these dummy mobs that we made in episode 92, I believe. And we have this chaser mob that we made last episode, episode 93. And you can see that he's distinguished by the red appearance here because we actually used a quick if statement to essentially reassign all of the purple pixels to be red when this actually gets rendered. So we did that last episode, of course. Now today, we're going to talk about actually giving this chaser some behavior. So I'm actually going to right click on this chaser thing up here and go close others. And I'll just close every other class we have open right now except for the chaser because that's really all we need for this episode. Now, let's talk about his behavior. In fact, before I do that, I'm actually going to go to the spawn level. And I'm actually going to get rid of these dummies that are spawning, okay? Now, all we'll do here is we'll actually just spawn one chaser, okay? This makes this for loop obviously redundant since we're only doing it once. We could have done that. That would have been the same thing. But the reason I am keeping this here, of course, is because I might want to change that in the future. I don't want to have to retype that for loop. So, yes, just to clear that up. So, all we're doing right now, if we launch our game, is spawning one single chaser up here. And what we want him to do is follow the player, yeah? That's all we want him to do. And this chaser entity, this chaser mob, is going to have an extremely simple behavior. Okay, he's not going to have some elaborate, you know, let's make this guy sniff you out like a dog and I don't know, work his way around walls and find the closest possible path to you. No, this is going to be simple. Okay, the more advanced mechanics of pathfinding and all those algorithms that we'll actually use to essentially transport a mob from point A to point B, you know, around walls and all that stuff. That'll be done in future episodes. But right now we want to start off pretty simple because these are quite stupid mobs, okay? So, you know, you have to, it's kind of like, think of this whole AI section of game programming that we're doing now. Think of it as almost like the life of a human, right? You start off like a baby, yeah? So like your behavior is pretty like, you know, I guess limited. You can't do really much. You're not super intelligent or anything. And as you kind of grow up, you get more and more smart and you can suddenly find your way around walls. Whereas as a baby, maybe if you see something out a window, you're like, oh, I'm gonna get to that, and you can't because there's a window in the way and you don't actually realize that. So, you know, that's what I mean by that. That was a smooth metaphor I just made up on the spot, by the way. But anyway, it's like a life kind of span. Okay, so that's why we're gonna start off small. Also, because if I dive into the complicated stuff, you guys are going to be like, Cherno, do those in-depth episodes you mentioned like half the series ago and never actually did about this stuff. So that's why we're starting off pretty small. So this is going to be simple, but of course not everyone actually knows how to do this. So please remember that for people who are going to complain about stuff like, oh, poof, A-star search algorithm, that's easy. Why don't you do something more advanced? No. Okay, chill out. I hate it when people comment being all like pretty selfish and stuff, being like, why on earth are you going over this? Because dude, like thousands of people watch this series, okay? Thousands. And the thing is, not everyone's gonna understand. So that's the way the cookie crumbles. Always wanted to say that. I do on a daily basis to my friends. What friends? Anyway. So yes, we're gonna make a actual method here. What should I call this? We might make a method here in update called, just think of a name here. I would call it move, but we want to go move method. Yeah, okay. We'll make one called move, okay? That's fine. We'll make it a private method. So private void move, okay? And the reason I'm doing this, we're actually going to move this up here, by the way. The reason I'm doing this, the only reason I'm doing this is because I just want to keep our code grouped over here. So that we don't need this update stuff. We don't need all this crap here. We just need to focus on the move method. Now the update method, it's probably a good thing to note, has all of our actual move code, and move of course references our mob class here with a public void move, which really should be protected. But anyway, I'm not going to change that now. And of course it handles our sprite directions as well as animations for walking. Okay. That's worth to note, and make sure you actually do have the move method in the update method, otherwise we're not going to move anywhere. So how the move method is going to work is essentially XA and YA, I believe is the way that, if we go over here, okay, this move method should really have this move as well, right over here. So let's actually cut that And yeah, I'm not sure if this is a good idea. That's all right. This will work though. It's just that because like all of this stuff is really like this direction stuff. It really does have a lot to do with actually moving. But that's all right because remember, move actually in update. This stuff is running. This stuff isn't running concurrently. It's actually running in what's the right word for this? I guess it's just running in order essentially, sequentially here. So because of that, this will get executed first and everything else later. That's probably fine. Yeah, and then at the start we can clear XA and YA. That works for me. Okay, cool. So in move, right, just to test this out, all I'm gonna do is we're gonna actually set XA equal to 0 every frame and YA equals to 0 every frame. And then let's just animate XA by setting it equal to ++ here. So if we launch our game right now, we should see moving right, and he does. Okay, brilliant. So that works. Just testing that. Okay, so now we can actually focus on the code that is I guess the AI. So what again, our objective for Chaser is just to literally chase the player, yeah? And we can do that by a series of if statements. Okay, this is quite simple. You guys could probably work this out if you did this in your heads or on paper or whatever. If you just thought about it for a minute. So what we kind of want to do, right, is we want to actually make him follow the player. Now, if you think about it for a minute, in order for us to make him follow the player, we need to know the player's position, don't we? Yeah, we do. Okay. We need to know the player's position. We also need to know, well, that's pretty much it. That's it. That's actually it. All we need to know is the player's position and the chaser's position. Chaser's position we've got because we're in here. Player's position we do not have right now. So because of that, we're actually going to have to make a method to get the player because currently we're unaware of what the player is. Now, how are we going to do that? Okay, there's multiple ways to do this, of course. This is what programming is all about. But the best way to do this probably at this point is in the level class, because every entity has access to level. And what level could have is a public void here that is essentially get player. Okay, sorry, not void. Public player get player. Now, the reason why I'm kind of cautious in doing this is because, of course, this game will support multiplayer. In fact, it'll be kind of like an MMO setup here, so it will have a lot of players. And because of that, we will need to make a system that deals with players, as in like an array list that deals with players for every single player in the game. But that's all right, because all we'll do then is we'll just simply change this method to this, and that's it. Okay, and then we'll just return the list of players. So don't worry about that now, okay? Because I know that a lot of you guys are worried about future-proofing this. Don't worry, I've thought about the future like every episode. So I am doing things generally making this series pretty sustainable as far as what I want to implement in the series goes. So we won't have to rewrite too much code. So public player get player, and we essentially need to return an entity that's a player. So how can we do that? Well, first thing we need to do is actually find the player. Now the player, I believe, does not have his own, no he doesn't, okay. So he's stored in entity, right? And we need to find him. So I'm just thinking, in fact, we should probably future-proof this right now. That's what I'm going to do. And the reason is it's going to be, because this method's going to be rewritten. What I was going to do, by the way, is just make a for loop. So if, sorry, I'll just show you guys what I was going to do. So for int I equals 0, I is less than entities dot size, all you have to do here, I++, of course, is just say simply that if entities dot get I is an instance of player, since there's only one, then we can just return entities dot get I. Okay, and that will work. In fact, let's do it this way for now, just because I've already written it out. And of course we need to cast player. Okay, and that's pretty much it. Otherwise we can just return null. So in other words, there's no player, which would be weird, but anyway. So what we need to do is first of all get a player object going. So player, yeah? And player will of course equal level dot get player. And that's really how simple this is. Now, if you want it to be really good with performance, you could do this, something like this. But we will get it every frame because that's probably the best way to do it. So if player.get, oh, we don't have any of this. So the entity class, not this entity class, the entity class here should really have get X and get Y. Not sure why it still doesn't. I'm pretty sure I implemented that episodes ago, but Might have been a dream. Public void get x, return x. Public, void int. Public int get y, return y. Okay? That's all we need. So back here in Chaser now, player.get x, as you can see that disappeared. So if player.getX is actually less, right, than, or in fact, let's do it this way. If our current x location is less than player.getX, then let's actually make sure we go forward. So in other words, by forward I mean right, okay? Pretty simple statement here. What we're saying here is that if our current, if the current chaser's x coordinate is less than the player's x coordinate, then let's make him move in the positive x direction, because that would get him closer to the player as far as the x-axis goes. Now, if we copy and paste this a further 3 times, we can make sure that we handle if x is greater than player.getX. In that case, we need to actually move left. If y is less than the player.getY, then we of course need to increase our y. And of course, same thing goes for if y is actually greater than player.getY. We need to actually subtract y to balance that out, okay? And that's all we need to do. So if we hit this up, we'll get a crash here with a null pointer exception apparently, which is a weird thing here. So hang on, am I right in saying that players, not that. Am I right in saying that player gets added to entities? I think it does. It would have to, right? Let's take a look at how we add a player, first of all. So, player, let's see. Do we have player? Okay, we do have a player in here. So, player equals new player, player.init, level. And, oh, look at that. Interesting. So, we never actually add player as an entity. That is pretty horrible design that I did. Well, it's not horrible design. It's just a weird way of doing it. And I guess we do use him here for the rendering logic. That is fine. Okay, interesting. Okay, interesting. So this game is made slightly differently than I thought it would be. And I'm sorry. It's just that it's been like a year since I started this series, and of course, my conventions and my way of doing things have evolved. And this series really hasn't. Well, in that sense anyway. So let's go back to level and let's implement it the way that I was going to implement it. And the way we're going to do this is we're actually going to make a private list that contains player, the object player. We'll call it players, and it's going to equal a new array list, of course. Player. Right? And let's import everything there. I think everything's already imported though. So now we have a list of players. And so what we need to do here is in player.getPlayer, we need to actually change this to be a list of players. Change this to be players. And and we can just simply, let's see here. We can just simply return the list of players. Now, one other thing we might want to do is get a public player, get player at or something, and put the index as a parameter, and then simply return players dot get I, or index in this case, sorry, index. And one other thing we might want to get is public player get client player. Okay, and I'm kind of thinking network thing here. That'll just basically return players.get 0, because no matter how many players are in the game, your player, the player on your client side will always be the very first one there, because of course that will get created first, as well as if it doesn't, it'll still get sorted. So we just need to really get the client player here. Okay, so now that that's sorted out, and we've got 3 methods to actually get players, we'll go to game here, which is our main class. And instead of initializing player this way and all this stuff, we're literally just going to hit up level.add player. Okay? And because we've done this, and sorry, we need to actually change this to an add player. Or in fact, did we make this universal? I don't remember. Yeah, we did. So let's put another else if here. So else if E is an instance of player. That does not work out. So if E is an instance of player, then we'll go players.add E. All right. And what's up? Oh, make sure we cast this, of course. Okay. And of course, we will initialize it here. So if we go back to game here, we can see that we do actually add it. And over here in update, we no longer need this. And over here in render, we no longer need this either. All right. So player X and Y are actually, we should really change this to get X and get Y, because they will return the same thing and they'll actually be in the entity class. So over here in player, because of that, we can now make sure that X and Y, which don't even exist to begin with, where were we getting them from? Were we getting them from entity? Yeah, so they used to be public. Let's make them private. And what will that do? Oh, sorry, not private. Protected. Protected. Okay. And we should have no errors with that, and we don't. Brilliant. So back in, this is a long episode, isn't it? Back in here. Yeah, okay, so we've removed it from update, we've removed it from render. Good. So level.render is obviously now where the player will get rendered. So we need to duplicate this for loop, and we've got a lot of them here, I know. And we'll go for I is less than players dot size. Oh, top layer. That's stuff from, I should get rid of that stuff, shouldn't I? This is from something else I was working on that I forgot to do. I don't think we've covered that yet. No, we haven't. I was trying to make a visual way to actually show collision detection, and I needed a layer of entities, or a layer of sprites at least, that rendered on top of everything else. So I had to make a top layer thing. Don't worry about that, that's irrelevant. We'll cover that later, if need be even. It's more of a diagnostic tool. So if I is less than, this is in remove. Let's get rid of this. I guess we're good. Players.size, we'll put this in remove as well. I'm pretty sure we've done this. Oh, have we? I don't know, this is the remove method. I keep forgetting to duplicate this project. Anyway, so for in I is, yeah, blah, 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 is less than players size. What we'll need to do here is actually, oh no, this is fine. So if players.get I is removed, then we need to remove that one. That's pretty simple. We also need to make sure that we're doing it for update. So copy and paste that. So for players.size, we need to make sure that we update every player, since we've removed it from the main game's update method. And we need to make sure that we render it finally. Now, players we want to probably render over here. We've actually got this thing here. So players.get I.render with screen, of course, as the parameter. And that's it. So if we run our game now, making sure that we get rid of this. If we run our game now, okay, what we should get is this player, you can see, chases us. Now, one thing that's not good about this is there's like literally no delay. That's a bit weird as well. Oh, so he's a bit offset, actually, as you can see. But he moves like the same way that we do here, which is fine. It's pretty funny. Okay, so if we try and run away from this guy, you can see that he literally follows us. See? He doesn't come to our exact position because I think the deal is that his coordinate is offset. So what we could do is, if we really wanted to clean this up, I think the deal is if we go into entity. Is it entity? No, it's chaser. The way that we render him is actually at X and Y, whereas if we go to player, we can see the player is rendered at X minus 16 and Y minus 16. So it's kind of like the center. So if we go back into chaser, and that's actually why collision wasn't working, now that I think about it from the previous episode. X minus 16, Y minus 16, if we launch this, he should stop pretty much exactly where we are, as you can see, okay? So, the coolness about this is that, well, he's perfect, and that's bad. He's actually perfect. You can see he's actually on us, exactly. And that's not a good thing. Usually not a good thing, at least, because he'll always get to us, no matter what, because he always takes the most efficient path, but he will lose us through walls, okay? So if I was to, for example, go to the player, sorry, go to game, and make sure that the player, the spawn location of the player here is at tile coordinates. It's maybe a bit, like 42. I don't know, this probably spawns in a wall. No, okay, so, yeah, okay. That kind of works. So I think I can, oh, okay, I'll be able to. Okay, let's run. Let's run. So he's behind us. But I believe if I wait for him to go here, yeah, okay. See, he can't get past the wall, obviously. He's colliding with it. And this is both, this is quite nice as well, because if you imagine like a zombie type behavior, he might not be able to get past that, and like, you know, that might be your game design idea. If you want him to get past that, you'll have to work out a pathfinding algorithm. So he has to look at this and say, okay, I can't get to you using this method. What is the shortest path or the longest path? Well, I don't know, or any path, or a random path I can use to get to your location that doesn't include walls. That's where the A* search algorithm comes in. Now, the point is though, we want to kind of get away with making AI as simple as we can, okay? And while of course we will cover the A* search algorithm in depth, well, I guess normally as we do in this game programming series, which is fairly in depth, yeah. We will cover that, of course, but before we do that, I do want to play around with this algorithm. Not today, of course, because we're at 20 minutes already, but we will play around with this method because, you know, as game developers, we want to kind of get away with making things as simple as we can, okay? Especially if you're doing something like Ludum Dare, where you don't have time, okay? And even if you do have time, this method is a hell of a lot faster than this method here, which is what we're using here, is a hell of a lot faster than having to actually implement A* algorithm for each of your mobs, okay? Without a doubt. So because of that, this is a much simpler solution. So next time we're going to take a look at actually kind of randomizing this, making him a bit slower to think, making him a bit slower to change direction, as well as making him just move a bit slower, or maybe just, you know, not be as sure as whether he should actually follow the player or not. Or basically, I guess, not be as sure as to where the player is exactly. And that'll just give him a more realistic, less robotic kind of approach to this. But anyway, guys, I hope you enjoyed this episode of Game Programming. If you did, please hit the like button. 200 likes equals 1 video per day, and 300 likes equals 2 videos per day. And so yeah, hit the like button if you guys enjoyed this video. If you didn't, please tell me, and I'll see you guys next time. Goodbye.